Hi everyone, my name is Audrey and Nsamela, and I'm super happy to talk to you today about my project, which is about microsumers and microfluidics, and more specifically, developing a microfluidic platform to study biological and biohybrid microsumers. First things first, I wanted to give you a little presentation about myself and my background. So I started by studying engineering at Université Catholique de Louvain in Belgium, where I originally come from. And then I did a master in physics engineering, which was part of a double degree with Polytechnique Montréal in Canada, where I spent 2 years after that doing a master in biomedical engineering. And I also got to do a research project for 1.5 years on functionalization of cold nanoparticles for breast cancer diagnosis. This was super interesting. And then I joined the consortium earlier this year in February to do a PhD in ActiveMatter, as you all know. And I'm doing it in ELVESYS, which is a company in Paris that sells microfluidic equipment under the brand ELVEFlow. And we do it in collaboration with TU Dresden in Germany with co-supervision of Juliana Simpson. And when I'm not working in the PhD, I'm mostly taking care of my 2 lovely dogs and doing hikes, enjoying the nature. So yeah, that's my life. So in the project, I will be focused on sperm cells and sperm's biohybrid microsumers, which is part of the biological biohybrid active matter. And as you might not be totally knowledgeable about microfluidics, here is a typical setup of microfluidic setup with ELVEFlow equipment. So you have a pressure controller that acts as a pump and will push your fluid from your reservoir into your microfluidic device, where you will perform then your experiment. And here I will visualize and observe the sperm behavior. And in your setup, you also have some flow sensors to measure the flow rates, or pressure sensors. You can have also other accessories. And this is all controlled by a software. So why using microfluidics is interesting and relevant in that project? Well, sperms naturally encounter flows during fertilization, and that actually helps with their natural selection. And so they naturally react and change their swimming behavior to these flows and to these other parameters such as viscosity. And we cannot totally observe them in a flow-free environment. This microfluidic can help recreating that natural environment, and also confining them helps with their visualization and the tracking, because they're all in the same focal plane. So the project will be divided into 3 big modules. The first one is about gradients. So I will be making a concentration gradient on chip to study chemotaxis behavior of sperms, for example, and probably evaluate different species of sperm. Then there will be a module about viscosity, so assessing the effect of viscosity, viscoelasticity on sperm behavior and swimming pattern, and then maybe do a sorting application with this. And the last part will be about sperm bots. So there will be a part where I will try to fabricate micro or nanoparticles on chip, and then I will try to control the fabrication of the sperm bots in a microfluidic environment, but this is for a later stage in the project. For now, I already have some results to present you. So I have done some simulation on the ANSYS Fluent software, which is a numerical simulation software for a gradient on chip. So I used commercial chip first from Chip Shop. And as you can see on the graph here, there is a pretty good correlation between the experimental data and the numerical simulation for the gradient profile across the chamber. So that was a pretty good news. And this helped me to build to design my custom-made microfluidic chip with that can serve many purposes. So I can make at least two different gradient profile. As you can see here that from the simulation, I can perform sorting or other things like that. So this is an ongoing process. And I also did experiments with the sperms. So we did motility studies in different viscosities. And we took the videos and we analyzed them with tracking software, which is called CASA, which is a plugin on ImageJ. And you get these nice tracking path of the sperm cells and other parameters such as velocities and so on. Sorry. So that's it for today. And I will be presenting a poster in the ActiveMatter conference on the 23rd of September. It's free registration, so you're all welcome to attend. Well, and I will be continuing with experiments, sperm on chip and viscosity, and maybe improving the CASA plugin to integrate new features. So thank you very much for attending this presentation, and I will be glad to answer your questions during the discussion time.